I think we can start, Satya, okay?
Yeah.
So, hello everyone, welcome to the session MCP in action, the real world use cases and design patterns. The session will be presented by Ms. Satya Karki. By designation, she is senior software engineer. She is also a Microsoft MVP, CSAP Corner MVP. So welcome, Satya, and we are excited for your session. Now, I want to just give a slight background about what this MCP is. So we have been seeing like how AI and AI solutions, AI topics has been evolved over last few years. The things are moving really fast, and lots of AI terminologies, technologies are getting evolved and introduced. So when we come AI need to talk with the data. Now, most of the time when we see GPT or like ChatGPT, it has been trained on some data. Now, when we want to utilize that same model for our own private data for any organization, we need to expose those data or we need to train those models with our data. Now, when it comes to MCP, we don't really need to expose our data or give AI entire data to train. Instead, we can build MCP, which is a kind of equivalent to API when we want to communicate with the other system. Likewise, the MCP work as a API for AI agents, AI models to communicate with the data outside of their training model. Saying that again, I would like to give this back because Satya will be sharing more context on this. With that, Satya, over to you. Maybe you can share your screen and we can start. If you are talking, you are muted.
Okay, thank you, Rishwan. Let me share my screen. I hope my slide screen is visible. Hello everyone, welcome. In this session, we will explore what is MCP, why we need MCP, real world use cases, its features, and how we can create the MCP server and the client using the Microsoft C# SDK. So this is the outline of the today's sessions. We will begin with what is MCP, why it matters, MCP architecture and core concept, MCP use cases. Then we will go for the how we can use the MCP C# SDK, MCP features, the C# SDK features for the .NET developers, and understanding the MCP server and the clients. Then we'll go for building a production-minded MCP server and the clients in the C#. About me, I'm Satya Karki. With profession, I'm a senior software engineer and I'm a Microsoft MVP, CSAP Partner MVP, and Microsoft certified trainer. I have more than 14 years of professional experience in software development and data, mostly with Microsoft technologies. So now let's begin with the topic. Before we jump into building and the MCP server, we need to understand why we need the MCP. So today AI systems, whether the LLMs, apps, browser, Visual Studio Code extensions, or the backend APIs don't speak the same languages. It has its own authentication. Each tool has its own custom APIs, its own authentication, its own integration models. So that means anytime when we need to connect the AI applications, AI clients to our backend systems or any other systems, we write a custom glue code in the each AI client application. So the over the time, this becomes very expensive, fragile, and insecure. So the exposing consume all the data, the backend side to the AI models, large language models, or the AI applications that will be the insecure when we work for the enterprise or the big organizations and expose our data to the public or the client. So it is going to be the insecure. So the MCP, model context protocol, solves this problem by introducing a universal standard protocols. So MCP, we can think the MCP as the USB port for the AI applications. One protocols that any LLM, any tool, and any application can understand. So suddenly, instead of the custom integrations for every system, we create the MCP tool once and reuse them across the different AI clients. This matters because we are entering an agent-driven era where the AI doesn't just answer the questions. It performs the actions, retrieves the enterprise data, automates the workflows. So the MCP provides structure, contextual, and the safe communication between the AI and applications so they can actually work together reliably. The key idea of the MCP is before the MCP integration with the custom and the isolated per AI application or the per AI clients. So after the MCP, integration becomes the standardized and reusable. So the one MCP can be reused in the different AI applications. And that sets the stage for why we need the MCP. So, and why the MCP is so important, especially for enterprise developers and the architects in 2026. Or in simple analogies, MCP acts as a universal connector or a one universal standard protocol to connect the LLMs, APIs, tools, local applications, and the cloud services for the enterprise applications or the cutting edge software developments where the AI plays the vital role. So the normal client application, as you can see in the diagram here, normal client applications calls the APIs directly. They can interact with the backend systems and our database through the APIs, or the some applications, monolithic or the old design applications directly call the backend systems. And MCP adds the tricks to the AI client applications. For the AI applications, MCP sits between the APIs or the backend and the AI applications. AI clients calls the APIs through the MCP server or calls the backend system through the MCP. And API calls the backend system or databases. So before the universal power adapter, every device had a different charger, constant tweaks, and the adapters. After the one universal adapter just works for the all. Similarly, MCP provides a single way to integrate the AI with systems. Now we don't need a custom integration per applications. So we can just do the integration with the backend or the APIs or the databases in a one application. That's the MCP, model context protocols, and that we can use in the all the other AI applications. So MCP replaces one of integrations with a universal protocol for tools, data applications, and automation. So now let's come to the use cases of the MCP, where we can use the MCP. We can use the MCP in the customer support automation, where the AI reads the customer cases details, calls the MCP. The AI applications calls the MCP tools, and MCP tools fetches the CRM records or the backends and updates the tickets and generates the responses. We can use the MCP for the DevOps agents for the LLM triggering the Kubernetes deployment, checks the logs, monitors servers, all through the standardized MCP tools. And we can use the MCP in a chatbots, running reports, aggregating the KPI, summarizing instantly the data, and so on. Similarly, we can use the MCP in financial compliance. For examples, the AI validates the transactions using the MCP tools to securely exchange. And for the local productivity, local software systems, and the other AI clients also, we can use the MCP for our own custom developments and integration with the backend and the data. So the other real old use case and the examples are we can use the MCP in the e-commerce product systems, for example, for auto price auto computations and the discount engine. We can use for the product catalog auto classifiers that our AI agents or the AI will help to product catalog auto classify it, and vendor data normalizations. In a booking and the travel systems, we can use the MCP, for example, the availability rules, inventory conflict resolutions, fraud, and the rule compliance check. Additionally, we can use for the notifications and the messaging cases where the we can push the push notifications, send the SMS text or the email actions trigger from the MCP. Additionally, we can use for the multi-channel message orchestrations for the notification and the messaging use cases. Additionally, we can use for the analytics tools that gives the trend analysis, dashboard data pre-processing, AI-generated insights, and for those purposes also we can use the MCP. These are some more real world use cases of the MCP. Use cases are not only limited to the this, we can use in the several other cases as well. So now let's introduce the MCP, the Model Context Protocols. The Model Context Protocol is an open source protocol that enables the seamless integrations between the LLM applications and the external data sources and the tools. We can integrate with the different other data sources and the tools that we will explore later in this session. Whether you are building and the AI power IDE, enhancing a chat interface, or creating the custom AI workflows, MCP provides a standardized way to connect your LLMs with the context they need. So the MCP is standard for how large language models talk to the tools. Instead of the custom APIs or ad hoc integration, MCP gives us a consistent model to tool interface. Think of it like this. The model asks for a capability, the server runs it, and then it returns the result in a clean structured response. It handles the discovery, execution, and the tool results automatically. It's also transport agnostic, so it works over the different communication channels. The most common transport is a WebSocket, but the same mechanisms can work across the other transports as well. So in short, MCP standardizes the interaction between your LLM and your tools and makes this communication predictable, secure, and scalable. And the MCP model is introduced by the Anthropic. Now let me walk you through the diagrams for the introduction and clearly understanding about the MCP. This MCP is an the standardized protocol, as you can see in the diagram. In the left hand side, there are the AI applications, the chat interface such as the cloud desktop, library chat, or GitHub Copilot, and ChatGPT or some other chat interface, some IDs and the code editors, Cloud Code, Go, Visual Studio Code, or Visual Studio. They can also the integrate and call the backend systems through the MCP. And the other AI applications, Friday, Superintendent, or other custom applications, they can communicate with the backend systems through the MCP, through the standardized protocol. So the backends can be the database and the file system. It can be the any other integrations with the any other development tools such as the Git, Sentry, etc., or the productivity tools like the Slack, Google Apps, and so on. And our database can be the PostgreSQL, SQLite, G Drive, or the MS SQLs. Anything can be in the backend side. And MCP sits between the AI applications and the backends and facilitate the communications between the AI applications and the backends through the standardized protocol. And this communication, as you can see in the diagram, it's a bi-directional flow, means MCP fetch the data from the backends and the MCP can execute and update the data into the backend side. So through the from the AI applications, we can retrieve the data, and also we can insert the data into the backend through the MCP server. So directly inserting the data into the database is not a correct procedure. That's may go for the security and the other vulnerability. So MCP provides the standardized protocols, and that sits between the AI applications and the data sources. So now let's go for the model context protocols architecture. This is also the almost similar like the previous. So the MCP is acts as an adapter for the data source. The MCP servers sits between the MCP client applications or the AI host or the other chat applications, AI chat application, cloud, ChatGPT, Coursera, or anything or any other your custom chatbots, and gets the data from the backends. The backends can be the files, databases, API. Even we can call the backend through the API, and the API can be called in the MCP server, and that MCP can be called from the AI application. So what's the components it has and how the interact standardize the setup. This architecture explains in the clearly. So at the top, you have the host, the AI applications or the enterprise environment embedding your LLM, for example, or desktop app, an IDE, or an the agent orchestration framework. The host doesn't talk directly to the server. Instead, it manages one or the more MCP clients. Each client maintains a dedicated stateful connections with a single MCP server. That gives a clean isolation, one client per server, so the resources boundaries remains clear. This allows the host to combine the context from the multiple servers, for example, one for the database access, one for the file storage, one for the remote APIs. So the we can do the different types of the integrations or the backend talk in the MCP server for the database, for file storage, for the API calls. Understand the food that the MCP's communications follows a two-layer design. The data layer, this defines the protocol itself based on the JSON RCP 2.0. It defines the primitives, tools, resources, prompts, and it also handles lifecycle management. For example, initial handshake, capability negotiation, request response, tool calls, resource fetching, and so on. And for the notifications for the real-time updates, dynamic changes. The transport layer, this is the communication between the this is the communication mechanism. MCP is a transport agnostic. Common transport includes the WebSocket for the remote servers, standard input output for the local server processes, and the HTTP for and SSE log pool for the remote web-based servers. So the today's demo I'll be showing in the local. So we'll be using the standard input output transport mechanism for the MCP and the client communications. Because the protocol layer is independent, the same message format works across the transport. When a client connects, there is a handshake, both sides declare their capabilities. For instance, I support the tools, I support the resources, and so on. So the other part is tools. These are the functions or the actions the server can perform. For example, run database query, read the file, call external API. So I'll be showing the external API call in the today's demonstrations and perform some computations, some calculations, so on. And resources, these are the contextual data. Data sources, for example, document, database, table, file, anything that an LLM may want to read or use as a context. Prompts are the standardized instruction templates for the few short examples to feed LLMs, helping with the consistent behavior. Because of this structure, MCP provides a modular, secure, and the flexible mechanism for AI applications to interact with the external system and the data without hard coding integration logic in all the application. So our overall host client server with the data layer and transport layer separations, capabilities, negotiations, and clearly defined primitives, tools, resources, or the prompts. That's the backbone of the MCP's architecture. And why it's suitable for the building the safe and reusable AI integration that shows it. So now let's go for the MCP SysApp SDK features. In today's demo, I'll be using the MCP SysApp SDK. So let's, before jumping into the demo, let's go what are the features available in the MCP SysApp SDK. MCP clients and the server is the number one features. We can build the clients and the servers in a minutes using the SDK's ready-made client and the server primitives. It is a attribute-based discovery. Attribute-based auto discovery exposes your methods as MCP tools and prompts with a simple scan. And another feature is MEAI integration, Microsoft Extension AI native plug into your DI hosting and the logging you already use in the .NET. The fourth one is a transport included standard input output for the local. It uses the standard input for the local and HTTP with SSE for streaming, production friendly hosting and the web applications. And it bridges to the chat stack, chat agents bridges, surface tools, edge callable functions in a chat client stacks. It works with any MCP server, server agnostic clients connect to the any conformant MCP server without lock-in. So now let's go for the demo. I'll show my projects here. I'll bring it to the So this is my demo project that I have built for this session. We have different types of the projects here. Let's begin with the share. The share just contains some models. These are just models with some properties. I'm using some records here for these properties. For this is a class. We have a calculation result class. We have a production item, to-do items, and weather info models here. So this is just a structure. Here we have a server, MCP server. Let's go here. I have used and the package that's the model context protocol. This is a SysApp SDK. And when I was creating this project, there was only the preview versions of this SysApp SDK. So I used the preview version, but recently they have release the another versions 1.1.0 version already came. So for the next developments, we can use for the latest version of the SDK or the current one also. I can upgrade it to the latest. I haven't upgraded yet. So this is the C# SDK and the project, the share is included in this project. So for the MCP here, we have a program.cs. So this configure this for the logging, that's the similar or is like the .NET. So for the API calls, the services, the HTTP API clients, that's the same. And let's configure the STP MCP server with standard input output transport. Is I will be showing this demo in my the local, so we'll be needing the standard input and the output transport protocol. When we deploy it into the productions or the web-based applications, then we will be needing the HTTP plus SSE transport protocols for the MCP and the server communications. So this is the configurations builder.the services add MCP server with the standard input server transport and with the tools from the assembly, whatever the tools you have. I have a tools here, several tools, the weather tools, I have product tools, product catalog tool, calculator tools, and the so on here. So we have to add all this into the assembly like this, and then the next is iHost Builder. Create here also the standard MCP server with the standard server transport protocol, and the other tools here like this. We have to do this configuration in the program.cs file. Now let's go to the tool. So the MCP we have these tools, also the calculator tool. So we use this MCP server tool type attribute. This is needed when this class got executes, then it will read this attribute and it will know that this is a server tool. So this attribute is really needed here. For example, we can create the different types of the tools. In simples, we can say the tools is like a service, such as for a calculator, we can create a calculator tool. For to-do items, we can create a to-do tools, and weather, we can create a weather tools. For the product catalog, I have created the product catalog tool, so on. And we write the MCP server tool type above the each tool class, because it is an attribute. This is an attribute used by the MCP framework to identify, categorize, and register the class as a tool in the MCP server. And the MCP uses the class scanning plus the attribute to find the tools. When the MCP server is start, it scans your assembly like this, find all the class, look for the attribute like MCP server tool type, then register those classes as expose MCP tools. This is similar to how ASP.NET finds the API controller, route, HTTP gate. We use those attributes for the MCP server tool. We create this, we have to use this MCP server tool type attribute. So you are essentially marking the class so that the MCP treats it as a server tool type. Additionally, each methods we use the MCP server tool and the description. This is the syntax to create the tools for the MCP server. Description is really needed when we call this from the LLM. So it gives the context and the details about what does this tool do and what data need to be sent, what type of the data type we have to send. For examples, in the calculator tools, this is a calculator tool. Calculator tool here, the class name, that's if we define the MCP server tool, this defined as a calculator tool is a one tool, and we have a calculator result, this as a add method. Each method counts as each tools, and for this method we use the MCP server tool this attribute, and we have to give the description of this method, so that what does these tools do, it defines, provides the descriptions, and it will be easy to communicate from the LLM based on this context. And for the aid, we have two parameters. So for each parameter also, if we pass the descriptions and the data type of the each parameters, then it will be easy from the LLM to call. And if the provided data type is a mistake, then it will be easy to throw the error messages about the data type. So this is how we have to follow this pattern in the coding. Let me show in the product catalog, so it will be easy specifically here. So this is a product catalog tool, and this has several other methods searching the product. This is a one tool, and here is a descriptions and MCP server tool types. And for this searching, we have and the items to the pass the product. So these parameters also we have to provide into the parameter with the description, data type, and then the name of the parameters. So similarly, here is a get product ID, add product. Let's go to the add product. This is another tool, another method in the product catalog tool. So this has us how many? Four parameters: the name, price, description of the product, and the is active we have to pass. So for this, we have to write the description of the each parameter, data type, and the name. So the LLM, when communicating with the LLM, it will be easy to talk with this. So this is how we follow these patterns for the each tool creation in the MCP server, and these tools directly call to the API. So in this product catalog, we have a product API here. This is a minimal API that I have created for this demo purpose. Here from this API, we can add a product, we can get all the products, update products, delete products, and get the products by ID. Those API endpoints are here. And from the MCP server, MCP server is calling this API. Calling this API here. You can see into the product catalog tool, the MCP server. This product catalog tool is calling this product API. The product API, the base URL is this. The API product API runs into this localhost port and gets the base API. So the search product API is one tool that searches and gets all the product from this base API, and how this MCP communicates with the API is here, and it just lists the APIs from the it just lists the product items from the API. Similarly, get product by the ID is another tools. It gets the APIs from it just calls the products from the API. So this is how we can integrate or call the existing API or the new API from the MCP server. And also this calculator is another custom tools that we can create, do some actions or some workflow automations, push notifications. We can create a push notifications tool and write the custom code there, and we can call this to the MCP AI client applications. Also, we can read some file or the database from this tool directly in the MCP, creating another new tool here, and then that tools can be utilized by the other AI clients. So we have a weather tool here that just gives the weather information. So this gives get the weather method we have that gives the weather informations, and get the forecasted weather, current weather, and the best temperature based on the different location cities and whether you need in the Celsius, Fahrenheit, that types. It's working. This is a custom tool that doesn't get the data from the backends. Just I have written for the demo purpose from the here. We can even the integrate the some other weather forecasted website or the some other third party tools. We can integrate here and get it. In the tool. So this is the server. So I have a AI clients here. This clients just calls the MCP. How it called? This is a console applications. Let's go here. I may increase the font more than it will be easy. All right. So the here it will just connect with the MCP server and just gets the server path with the server path arguments, and it just gets the server MCP server path. Currently it will be running in the local, so it will get from the my local MCP server path here, and once the server path it gets, then it will go and it will do the some actions here. So it will be connected with the server, and then as you can see, the standard input output client transport protocol it uses, and the clients will be connecting to the server through the standard input output protocol. For the local, for the hosted or the web, it will be using the HTTP plus SSE. So the once the server is available, it will get the connected and the creates the connection. Then once it gets connected to the server, then it just lists the available tools. So this is the method where what are the tools are available in this server. Just this method list out the gives the list of the uh, tools. So here we have these much tools, calculator, product catalog, product, text utility to do, and the weather. So when we run this, it will just list all of these tools from the server. So the once the server loads these tools, then it will run the interactive demo. So in the interactive demo, I have these methods. Let's go to this. So here it just gives the list, and based on this and the tools whatever the user has selected, it provides the informations. I have used the switch cases here. If the weather tool, then it gives it will show the informations or gives the record about the weather. If we select the calculator, then the calculator method we have there, and it will give the calculator. Let's go to the weather here. So the if the weather, then it will gives it will just executes the this course and gives the when gets the weather informations from the tool. So the in the weather tool we have done some for we have some for we get weather forecasted and the current forecasted method. So it will gives the forecasted and the current weather of the particular locations. So now let's go and run it. So before it, I'll just run the API also, and then I'll just run the for this project. So I have to run the server, and the clients should be running. Then the clients can communicate with the server. Now let's come to the API. This is the API. In the API, I have 10 products. Here we have 10 products. List of the products and the different API endpoints to update, delete, and get the products by ID. Now my server and the clients is running. Here. Okay, this is a client application and this is a server is running in the background. my client is a console applications. AI client is a console application. So here you can see the once this is connects client is connected to the uh, MCP demo host. This is connected with the MCP server successfully. So it just lists the all the methods of the each tools. These are the each methods are counted as the products. We have get products. So we have update products, extract the URL, update the to do, create to do. So these all are the tools listed as I already demonstrated in the code. Once it is connected, it will list the available tools here, and then we have we'll run the interactive demo. In the interactive demo, if we select the each tool name, then it will give the informations about that. So now let's select we have four tools as in the code. You can see we have this much of the tools created here for this demo purpose. 1, 2, 3, 4, 5, 6 tools. Now we have all these six, and the clients is now able to list the all of these six tools. Whatever the tools you want to integrate, we can call from the here. So I'll call the I'll select the one choice, that's the weather tools, and I want to so get the current weather. So I will select this. Now I will provide the Tokyo. Then it will give the ask for the whether you need in the Celsius or the Fahrenheit. Let me give in the Celsius. Then it is just displaying the current temperature of the Tokyo in the Celsius. So the 15 degree Celsius is the current weather of the Tokyo. So this is how we can interact. We can see the another. Yes, I'll go another. I'll select the current weather or the forecasted weather to enter the Tokyo. Okay, Tokyo forecasted weather. I will need then how many days of the forecast. I can say the 5 days. Then it will give the 5 days of the forecasted temperature of the Tokyo. So similarly, we can do like further. I need to now also for the product catalog tool, I'll select the six. And I'll select the search all, choose the actions what I need. I want to search the all the product items here, so I just provide the information. So now you can see the client is able to list all these products from through the MCP. So client now able to talk with the API through the MCP. We haven't done the anything about the API in our client application, as I already demonstrated here. We don't have a client, and this is API in the client. We haven't done the any connections, anything with the API or the backend here or the anything. It's just we are just using the server. We are just calling the server into the AI client applications, and through the MCP, it's able to get and read the data from the API. So this is how the MCP acts, and the MCP sits between the AI applications and the backend or the API. So we can just call the API or the backend through the MCP server in our AI applications. Let's run the another methods. For examples, I want to do the product catalog 6. I'll select the 6, and I want to get by ID. Okay, I'll select just the search the 3. 3 means then I need to provide the ID for the product. Let's put the 10 or so the for the 10 we have on the smartphone for ID 10 we it's giving the informations about the smartphone. So if you see in the API, the ID 10 smartphone has a ID 10, so it's able to get the product from the from calling from the API in our AI application. So that's how the concept behind the MCP server and the client come, and how we can use it into the real world applications or in our enterprise application developments. So this is all for the demonstrations for the server and the client. Beside this, I have created another demo project in the Blazor. So it's really sometimes difficult to understand from the console applications. I have this demo Blazor application developed for the client application. So let me show the quickly how we can utilize into some interactive applications like the Blazor. So this is a Blazor client AI applications. This also connect with the MCP server. So here is a connect button. I just clicked it, and the connection is status history is a connect. It is connected to the MCP server successfully. And this side I have listed all the available tools here. So we can see the all the available tools. Whatever the tools I can we need to communicate from this application, we can just select. For example, let me go with the get weather. Where is the get product? Here the get weather tool is here. So I just need to provide the parameters, Tokyo and the unit. I'll just go from the here. Provide this parameter. That we can use some interactive UI for this demo purpose. I have just passing the parameter in the JSON format. So we can do this in the drop down or some selection, input parameters from our chat interface or some interactive AI applications and call the MCP there. So now here we can see the Tokyo's current temperature in the Celsius. So this is how the AI clients interact with the MCP, and MCP interact gets the data, fetch the data from the backends. So similarly, we can upgrade the data into the our backend systems or database, or we can call the update API endpoints in the MCP, and that we can utilize into the MCP client application. So that's all for the demonstration that I have. Now let's move to our presentation slide. Let me open this. So this is how. So let's come the how the communication between clients and the server occurs. I just want to give one summary for the remote MCP servers. It runs as a independent processes accessible over the internet using the HTTP based transports like the streamable HTTP, enabling the MCP clients to connect to the external services and the APIs hosted anywhere. For the local MCP servers, MCP clients uses the standard input-output edge and the local transport method to connect to the MCP servers on the same machine. So in this demo, I just use the standard input-output transport protocol for this demo, as well the both the servers and the clients was running in my own demo machine. So now let's go for the what are the features and the functionalities. We can add different types of the features and functionalities in a MCP server, such as data handling and the transformations are a common backend tasks that the MCP servers can automate. For example, it can use for the data validations, null or the empty checks, type validation, business rule validations. Example, price must be greater than this value or that value that we can do and add this data validation checking in the MCP server. Additionally, we can do for the data enrichments, add a missing fields, look up metadata from external APIs, auto-generate the unique IDs, time stamps, etc. Additionally, we can use the other features in the MCP such as the data transformation, normalize the consistent product fields, convert the format CSV to the JSON and the custom schema, and so on. Additionally, we can use the MCP for the business rules and the workflow automation, such as the workflow orchestrations. Just for example, trigger the multi-step operations, create a order, reserve the inventory, send and then send the confirmation. For scheduled tasks like the data sync jobs also we can add. We can add the rule engines in the MCP server, such as implement the domain logic, such as booking availability rules, price rules, discount eligibility, inventory restriction, fraud detection logic. Those we can add into the MCP server before hitting to the backend or the getting the data or any actions performing in the backend system from the AI applications. Other things that we can add into the other functionalities that we can add into the MCP server is a event driven actions. When the X happens, we can trigger the Y, or the now the booking is done, then the send the SMS. When the payment is a failure, send the email to the customers. Those kind of the data driven actions also we can do in the MCP server. Another features that we can add is integration with the external systems, such as the API integration that I just demonstrated in the demo, that we can integrate with the APIs, we can integrate with the other, we can call the other database file systems, or we can make any other the custom MCP tools with the custom rules and the validation workflow or some calculations, those kind of things. For API integrations, MCP tools connect to the product APIs, get the payment gateways, or it can connect with the CRM, ERP systems, or the AI models, third-party data sources, or the third-party, the one API can call or into the another external third-party APIs. That way also we can call the third-party applications from the multiple APIs also in the MCP server. Similarly, the other microservice communications that wrap the internal services under the unified MCP tools, that also we can do. And the gateway layer for multiple services also possible. And AI enhanced capabilities such as summarization tools, summaries of the logs, orders, bookings, user messages, those also can be done in the MCP. Or the classification tools detect the intention, categorize the product descriptions, auto tagging items, and recommendations tools suggest the products, plans, or the next workflows that can be done. Similarly, other features and the functionalities for data cleaning and normalization, AI can fix the consistent product names, description, etc. that we can clean the data and normalize the data through the MCP server from the client MCP client application or the AI client applications. That's also possible. The other features are the security, logging, governance, authentications, and authorizations limit the tool access by the user role, multi-tenant logic, audit logging. Every tool can call, be logged, who called, what data was sent, what the result was returns, to that the audit logging purpose also we can use the MCP server. For rate limit, throttling, prevent the misuse or the overload, that purpose also we can use. And monitoring and the metrics, expose the tools, label, latency, errors, uses, and the statistics, we can use the MCPs. For debugging and the diagnostic tools also, inspect the system config, fetch environment variables, and the check batch processing and the background jobs, sandbox tooling, and the so on. We can do the several other features and the functionalities in the single MCP server, and that the single MCP servers can be reused into the multiple AI applications. So as the AI applications are growing, each organization can have several type of the AI applications that need the integration with the backend or the other systems. So they don't need to do that integration in the each AI applications. They can just create a one single MCP server and reuse that MCP server in the all the AI applications. So that's all, and the summary about the MCPs, that the MCP replaces the one of trade-off between uh, the AI applications and the backends. Thank you. I hope you found these sessions valuable. Now, I would love to hear from you. Any questions, queries, please feel free to ask. As well as if you have any questions, concern, then you can connect with me in the LinkedIn, or we have a cloud expert group or community, and also we have a .NET Gold community. So if you have any concern question, you can raise there, that I will be answering, and the other community members also will be answering your doubts and the concern. Rizwan, over to you.
Thank you, Satya. I think it was a wonderful session with hands-on experience. I think those who ever watching, they will have a very good understanding of MCP and how they can do. Really, really good session. Appreciate your time. And with that, I think we are good to close. Do you have any final thoughts? If not, then maybe we can end the call, in the session.
Yeah, I don't have anything.
Thank you. So thank you once again. And the
Yeah, another
record.
one thing that I will mention, if someone want to explore this project, I have a GitHub and I have already uploaded there. We can share this project through our community. Yes.
Sure. So we can add that GitHub URL into Meetup. With that,
Mm-hmm.
also
Yeah.
the recording of this will be uploaded into YouTube, where they can go and refer back if they want to see something.
Okay. Yeah. Yeah. That's great.
Once again,
Okay.
thank
Thank
you.
you, Rizwan, and
Yeah.
thank you all the participants. Have a good,
Yeah.
great day. Bye bye.
Okay. Have a good day, everyone. Thank you.